Hello, you're welcome back. Okay, so let's still continue. Okay, so this time around, we are going to be looking at some question on basic concept terminology. So here I have a very first question. Here it goes this way: define uh, the following: isothermal, isobaric, and of course isochloric process. So when you say process said to be isothermal, the word iso means constant. All right, so it means constant. So answer. Okay, so an isothermal process is a process that occurs in a please pardon me, at constant temperature. So that process occur at constant temperature, so it's called an isothermal process. So the same way they can actually define the others. So isobaric is constant pressure. Isobaric is constant, a process that occurs at constant pressure. Okay, isochoric is constant volume. So constant volume process. So take note of those important definitions. All right, so let's proceed. Um, okay, so this is another definition. The question goes this way: what is the difference between intensive and extensive property? Now, in thermodynamics, okay, in thermodynamics, extensive, a property is said to be extensive property. Okay, if it is mass dependent. Okay, so it's their properties that depend on the mass of the system. Okay, mass of the system, or even the size of the system. So they are, let's say, the higher the mass, uh, the the mass, of course, actually will affect that particular property. All right. Example: let's look at those properties that depend on the mass of the system. Okay. One of them is total volume. Total volume of the system. Total mass of the system. Okay. Of course, even the energy, the total energy of the system. Total energy of the system. They are extensive properties, etc. So because their value actually depend on the mass of the system. For example, total volume of the system will increase when the mass of the system, all right, of the system actually increases. Okay, so please take note of that. Now, while on the other hand, intensive property, okay, it's a property that does not depend on the mass of the system. Okay, so of course, example is we have the pressure, temperature, density, etc. All right, so those are intensive properties. All right, so let's look at this phenomenon, quasi-equilibrium process. You know that at equilibrium, okay, actually it's a thermodynamic equilibrium is a state of stability, it's a state of balance in which there is no change, okay, there's no change that is actually occurring. The system is not undergoing change. When a system is said to be in a thermodynamic equilibrium, right, it simply means that the property, a particular property is the same throughout. For example, um, thermal equilibrium, all right, exists in a system when the temperature throughout the system are equal. So there's no change in temperature, because temperature only changes if there's a difference between if there's a difference in temperature of one part of that system and the other part. So there's going to be a change in temperature. Since the temperature is the same throughout the system, then of course the change in temperature is equal to zero. In thermal equilibrium, all right, delta T, change in temperature, is equal to zero. The system is not undergoing change. But anytime you hear of the word quasi-equilibrium, so this is a very slow process. Even though there's a change that is the system is undergoing change, but the change is too slow. The process is too slow, okay, that at each point of the process, the system the system is assumed to be at equilibrium. Quasi-equilibrium process, okay, is a very very slow process in which in which any state any state of the process seems to be at equilibrium. So the process is too slow that even though the change is actually taking place, it's too slow that the system, okay, seems to be at equilibrium. So please take note of that. That's what quasi-equilibrium process is. Okay. Now let's look at this particular question right here. It's a question that is, of course, based on density and relative density. So the question goes this way. A 3 kg plastic tank that has a volume of 0.2 meters cube is filled with a liquid water. Assuming the density of the water is 1000 kilogram per meters cube, determine the weight of the combined system. Okay. So of course, density we know is mass all over volume. Okay. Now, the density of water is 1000. So the mass of the water, right? The mass of the water is what we don't know, okay? But we know the mass of the plastic. So what we have to do is first of all find the mass of the water. So divided by the volume, okay? So now the volume there is 0.2 meters cube. So and that's still gonna be the volume of 0.2 meters cube. So invariably the mass of water, if I cross multiply, that's gonna be 0.2 times 1000, which of course is 200 meters cube. 200 not meters, 200 kilogram. Okay, am I mistaken? Let me read again. A 3 kg plastic tank has a volume of 0.2 meters cube, okay, filled with liquid water. Assuming the density of water is 1000 kilogram, okay, determine the weight of the combined system. Okay, so this is actually the weight of the water inside the tank. So the total, this is the mass of the water inside that particular tank. Okay, it's called a tank, of course. So invariably the total mass is going to be equal to the mass of the water, then plus the mass of the plastic, which is 3 kg. So that's going to be 203 kg. So we are asked to calculate the total weight. So total weight, of course, is going to be mg. Okay, that is 303 times 9.81. Let's calculate that. Okay, so here we go. 203 times 9.81. Okay, so the total weight is 199 how many? Okay, 1.43 Newton. All right, so that is by the way. Let's proceed. There are more questions that we need to actually solve. So here, this is a question on hydraulic press. Hydraulic press is actually a device that is used to transmit pressure from the effort to the load. So effort is applied at one arm of the hydraulic press. Okay, then it uses fluid to transmit pressure from the effort to the load so that the load will be lifted up. So invariably, the principle of hydraulic press is this: the pressure that is generated at the effort P1 is equal to the pressure that is transmitted to the load. So P1 is equal to P2. That is the principle of hydraulic press. Okay, P1, the pressure of the effort is equal to the pressure of the load P2. So pressure, you know that pressure is force all over area, so that invariably, okay, so we can say that the F1 all over A1 is equal to F2 all over A2. So this is the formula for hydraulic press. Now in this case, now we know the weight on the effort. Okay, we also know the weight on the load. We know the diameter of the effort piston, but what is unknown here is the diameter of the load, which is D2. So of course this is going to be equal to the weight of the effort, that is 25 times, that's mg, right? F1 is mg, so m1g. Okay, so 25 times 9.8, so just put that 25 times g, which is 9.8, then divided by, that's 9.81, then of course divided by the area of a cylinder is pi r square h. It's the surface area of a cylinder. Okay, of course it's pi r square. So since it's being given in diameter, so we can put it this way: this is going to be pi d1 square all over 4. Area of a circle, of course the cross-sectional area is actually a circle. This is a cylinder, so it's a circle. That's why it's given in cm. So in this case too, we know already that the weight is 2500, then multiply by 9.81, then divided by pi. Okay, so this d2 square all over 4. So of course d all over 4 is found at the numerator of both sides of the equation. It will cancel out. Okay, so since I'm looking for d2, so I can make the d2 the subject. So if I make the d2 the subject, d2, okay, of course square, this is going to be equal to, invariably that's going to be equal to cross multiplying, that's going to be 2500 times 9.81. Of course divided by 25 times 9.81. Okay, 250 times 9.81 d1, okay, times d1 square. Okay, so we can actually cancel out this will go. If this divide this, that's going to be 100. So that simply means that d2 squared now is going to be equal to 100 multiplied by d1, and of course d1 is 10 cm. So that's going to be 10 cm divided by 100, 0.1. Okay, so of course that's 0.1 square. Okay, so now so let's calculate. So this is going to be equal to 100 multiplied by 0.1, 0.01, which is 1. d2 square is, of course, is 1. So that means d is going to be equal to the square root of 1, which of course is 1. And that is 1 meter, measured in meter. Alright, so 1 meter or 100 cm. So please take note of that. Take note of that, is really very important. Alright, so let's proceed. Now this is a diagram. In this question, this is actually an aircraft flying at this altitude of 3 kilometers. Okay, soaring through air, and of course the absolute pressure measured at that altitude is equal to 58 kilopascal. Of course, you know the formula. Okay, you know the formula that the absolute pressure is going to be equal to the atmospheric pressure acting at that altitude, then plus the gauge pressure. Okay, the gauge pressure is measured as the density of the air multiplied by acceleration to gravity, then multiplied by the altitude h. So in this case, we are being asked to calculate the atmospheric pressure. We know the absolute pressure, which of course is 58. Okay, and equal to, okay, the density of air was given. Okay, take the density of air to be 1.15. Okay, so 1.15 is the density. So here P atmosphere ATM is equal to density of air 1.15 times 9.81, then multiplied by the height, which is how many? That is 3 kilometers. So that's going to be 3,000 meters. 3,000 meters. So invariably now, of course, I have to convert this is kilopascal. So convert that to pascal. That's going to be 58,000 pascal. So that means the atmospheric pressure is going to be equal to 58,000 pascal. Then minus, let's calculate 1.15 times 9.81, then multiply by 3,000. 33844.5. Okay, 33844.5. So let's subtract. To 8844. Okay. Oh, please pardon me. This is 58,000. 58,000 minus 33844.5. 24155.4.5. So the atmospheric pressure is 24155. Of course, that is going to be in Pascal. So if you want to express it in kilopascal, that's going to be 24.155 kilopascal. Okay, so please take note of that. It's really very important. Okay, so is there any other question? No, no other question. So that is it for this video. We're going to look at more in the next video. So see you in the next video. Thank you very much.